Oogenesis is the process of developing ova or egg cells within the ovaries of females. Folliculogenesis is the growth of all of that granulosa and those other structures around the oocyte. So, this process, folliculogenesis, is covered in another mini lecture of mine called Ovaries and Ovarian Follicles. This mini lecture covers only oogenesis, which is the cellular divisions that the ova experience. Neither of these processes are the processes that take place in the uterus. Both folliculogenesis and oogenesis take place in ovaries. However, the cells that are involved in oogenesis and specifically in folliculogenesis, they generate the hormones that dictate the uterine cycle. Let's clear up some other terminology quickly. Oogonia are stem cells. Oocytes are those stem cells going through the stages of meiosis, and that's happening in the ovary. An ovum, or plural ova, is technically what's ovulated out of the ovary to meet up with spermatozoa. However, I've taught from non-science majors textbooks that refer to oocytes as ova, but technically it's an ovulated egg. Oh my God, don't use the word egg. That's a terrible word. It refers to all of these structures here. A zygote is a fertilized ovum that has already met up with sperm and is ready for implantation into the uterus. Unlike sperm production in the male, the process of oogenesis begins during fetal development instead of at puberty. The oogonium is a stem cell, and there's many of them, and they contain a full set of chromosomes called a diploid number, right? So you get 46 chromosomes in every cell. These are found in the outer region or the cortex of the ovaries, and they undergo cell divisions during fetal development, and they produce millions of cloned or copied cells. Most of these are degenerated before birth, right? Like, why make so many just to get rid of them? But some of them are stimulated to grow into a slightly larger cell, which is called a primary oocyte. These are cells that have begun their first cell division of meiosis in fetal development. They don't complete it, and they remain suspended in this like partial state of division until a date much later in the individual's life. At birth, only about 400,000 to 4 million oocytes remain in both ovaries combined. Oogonia are not present, meaning that this supply of eggs is the finite number for life. At puberty, about 40,000 ova remain, and the meiosis process is now strictly regulated by estrogen and progesterone. Every month, there are a bunch of oocytes that want to be picked to ovulate. About 25 to 30 oocytes will restart and fully complete meiosis 1. However, unlike the equal divisions of cells in spermatogenesis, in oogenesis, the divisions create one big oocyte and one little tiny polar body. A polar body is not like an official cell. It's kind of like an inactive cell, and it has no purpose. It holds 23 chromosomes, just like the primary oocyte, but during cytokinesis, when the cytoplasm is divided among resulting cells, the polar body received little to none of the organelles that would allow it to get started with making the proteins essential to life. So now we have 25 to 30 primary oocytes that are responding to rising levels of estrogen at this point. And they all want to be ovulated and potentially fertilized. As a side note, they are all contained in tertiary or Graafian follicles at this time. All of these, they start to enter into that second round of cell division in meiosis 2. This round of cell division might or might not create a second polar body, but it definitely creates a secondary oocyte. This secondary oocyte is again arrested before completing meiosis 2. Hopefully, it's ovulated and it'll complete meiosis 2 upon joining its chromosomes with those from a spermatozoa. Sorry, spermatozoon. If the secondary oocyte doesn't get ovulated, it's going to try again next month, and then the next and the next. At some point, it might give up and it might be lost to atresia or breakdown. Menopause it's got a couple different definitions, but in terms of hormones, it's defined as a drop in estrogen, which is usually the result of the end of oocytes to ovulate. The ovary at this point usually has numerous corpus albicans, which look like scars upon the ovary. Menopause sometimes can be specifically defined in terms of time as the first year without a uterine cycle, which would indicate no estrogen. That doesn't mean that there are absolutely no oocytes left just because you're not having a cycle. There may be some. They may refuse to ovulate each month. They might be like, hey, I'm not ready. Can I get back to you next month? And this can create skipped months of the uterine cycle leading up to menopause. There can also be a bunch of oocytes one month that are like, hey, this could be our last chance. Let's all ovulate together, which can sometimes cause multiple pregnancies in years leading up to menopause. This period of time leading up to that first year without a uterine cycle is also called or referred to as perimenopause, which, in my opinion, has a lot of symptoms that were way worse than menopause. I'm sorry for that personal, but I am 50 years old. I mean, you get an idea of where I am in life.